So this is going to be our first little bit on doing what I'm going to call stoichiometry or stoichiometric calculations in chemical reactions. This is going to be challenging. This is going to be hard, okay? So we're going to take it one problem, one reaction at a time, okay? So we're back to this reaction that we talked about earlier. So this is the reaction of propane, okay? And whenever we see a chemical reaction, the first thing that I want you to start thinking about is it balanced? Is the reaction balanced? And if not, before I do anything, I have to balance it. So hopefully you can tell with all these blank spaces, the reaction's not balanced. So we've got to balance it. And as you recall from last time we did that, these numbers were 1, 5, 3, and 4. Make sure you can get to those numbers, right? We did that last time, okay? And so now, this is not so much a question of how much CO2 will this reaction produce, but instead it's how much oxygen will react with 96.1 grams of propane. And so what we're going to start doing, we're going to start really seeing these kind of big, complicated word problems, and we need to be able to calculate any quantity asked from us for a chemical reaction, okay? So I'll say that again. I want you to be able to calculate any quantity that's asked of you in a chemical reaction. So we have to read this question critically. We have to use some critical thinking to know what's going on. Okay, so it's asking us, what mass of oxygen? Okay, well that's going to be my final answer. My final answer is going to be mass of oxygen. Okay, so just tell yourself that. My final answer has to be mass of oxygen. What mass of oxygen will react with 96.1 grams of propane? Okay, hopefully we remember that's the propane. Okay. And hopefully we're also starting to recognize the process. We're going to use the first number I was given first. And in this case, of course, it's the only number, but all the same, it was still the first number I was given. So I'm going to write it down blindly. 9.61 grams of C3H8. That's how we're going to start this thing. Okay? So now what I can do from here is the same process. Down, up, down, up, down, up. So I know what I need right here is grams of propane to make these two things cancel, right? And so what am I going to replace that with? Hopefully you said the molar mass, okay? And if not, then this is why we want to use the molar mass, okay? I can see in my reaction that for every 1 mole of propane, I need 5 moles of oxygen. It's a 1 to 5 ratio to make this reaction happen, okay? So what I really need to do is convert this grams of propane into moles of propane. So we're going to write that down for reactions with chemical reactions, okay? If we have grams to start with, and I'm going to say grams of reactant, I need to make that into moles of reactant, okay? And I can do that with the molar mass. And to calculate the molar mass, I take 3 times the average mass of carbon plus 8 times the average mass of hydrogen. Boop, 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 boop. You should get 44.097. So where does that come from? That comes from saying, I know hydrogen is 1.008 times 8 equals, and that's going to be plus 3 times 12.011 for carbon equals 44.097. That's where that number came from, okay? So there's that number of grams in 1 mole of propane. And I know a lot of you are just going to want to calculate this thing and stop. Okay, I turned grams of reactants into mole of reactants. Let it ride. Let it keep going. Okay? So now I've canceled that. So now, if I have grams of reactants, I convert it to moles of reactants. Now I want to go from moles of reactants to moles of product. how do I do that? That's a little bit trickier. Okay, so again, the reaction tells me for every 1 mole of propane, I need 5 moles of oxygen. So remember, I still have to do the right order of units, down, up, down, up. So I want to cancel mole of propane. I want to convert moles of propane into moles of oxygen. Convert moles of reactant into moles of product. Okay, so I'm going to convert mole of C3H8 into mole of O2. Well, how do I know which number to put? Well, my balanced reaction tells me for every 1 mole of propane, it needs 5 moles of oxygen. Okay? So you can put it just as another line right there. Okay? And then now this problem is asking me what mass of oxygen. So finally I can go moles of product into mass of product, and I'm going to use the molar mass of oxygen. I'm going to say 1 mole of O2, right? Because I want the mole of O2 and the mole of O2 to cancel. And I know from my periodic table, each oxygen is 15.999 times 2 gives me 31.998. We'll keep all those digits. Why not? Grams of O2, and then now everything's canceled and I'm left with grams of O2 in my final unit. So that's going to be the final unit of my answer. So equals grams of O2. Now what about the number? Okay, I'm going to say here 96.1 times 1. I'm pointing it, but like you can't tell where I'm pointing. So 96.1 times 1 times 5 times 31.98. Okay. Equals, okay, times 5 equals times 31.998 equals. Now I'm just going to keep that number in there, and I'm just going to say divided by 44.097 equals. And let's see, I don't have any other numbers to worry about here, okay? Just, I could say divide by 1 and divide by 1. And then I recognize the 96.1 is 3 sig figs. So my final answer is going to have 3 sig figs. So to me, that would be 349 with 3 sig figs. 349 grams. So what does all of this mean? Well, what this means is 1 mole of C3H8 needs to react with 5 moles of O2 for both of them to be completely consumed. So think of this as like baking or cooking or whatever, right? It's a recipe, right? If I want to react all 1 mole of my propane, I need 5 moles of oxygen. Well, now that's the exact same thing as saying 96.1 grams of this will react with exactly 349 grams of this. Okay? That's all that we did. We just said if 1 mole of propane needs 5 moles of oxygen, that's the same thing as saying 96.1 grams of propane needs 349 grams of oxygen. All right? So make sure you're able to do that. I'm going to move on to another problem, another example problem, and it's going to be a little bit harder. Okay? So I'll show you how we add on those extra details.